Hello, good morning, everyone. We are just waiting for a couple more minutes and we will start our meeting.
Good morning, everybody.
Good morning, all. So today, on behalf of Indian Institute of Soybean Research, I welcome all of you for our today's webinar. The topic of our today's webinar is Precision Agriculture for Meeting Sustainable Development Goals. And the speaker is Dr. M. Karthikeyan from National Chemical Laboratory. So on behalf of our institute, I welcome all the distinguished speaker, Dr. Karthikeyan, all the participants from different institutes and AICRP centers. So I just ask Director Dr. Nita Khandekar to welcome our guest. I'll just check if she's joined. I think she's still not here. So we'll just wait for a couple more minutes. Hello, Dr. Karthikeyan. I welcome you on behalf of ISR. Can you hear me? Dr. Karthikeyan?
Yes, Dr. Milind.
Yes.
I am trying to make my background presentation slide. 1 second.
Okay, sure.
सर आप म्यूटेड हैं।
रत्न पारखे सर आप म्यूटेड हैं।
Yeah, once again, I welcome all of you for our today's webinar. And I'll first introduce our speaker, Dr. Karthikeyan. Dr. Karthikeyan is a senior principal scientist at the National Chemical Laboratory, Pune. He did his bachelor's and master's in chemistry from Pondicherry University. And later he joined for PhD at National Chemical Laboratory in chemistry. So his major topic was organic synthesis. After PhD, he worked in the Ministry of Defense, DRDO, for a couple of years, and later joined the National Chemical Laboratory as senior scientist. His main research has been in chemoinformatics and high performance computing. So his major expertise has been handling large-scale molecular data and searching the web pages, 10 billion web pages, and searching chemical information from different internet sources. So his current research includes metabolomics, precision agriculture, development of open source tools in visual computing for molecular informatics. And in last 30 years, he has published several papers in national and international journals. He was also a visiting scientist to US in the University of North Carolina. And he's a member of advisory board of several journals. So I have been following his research for more than 25 years, and he has passion for chemistry, for big data, and for agriculture. So he is using his expertise to developing new tools which can help the Indian farmers. And today he will discuss mainly on the low-cost weather monitoring system which he has designed in collaboration with other institutes. So once again, I welcome Dr. Karthikeyan and request him to give his presentation.
Thank you, Dr. Milind. First of all, thank you to the organizers for inviting me to give this important topic, and that is precision agriculture for meeting sustainable development goals. And this is my passion. Basically, as Milind said, I am an organic chemist and eventually developed interest in computer science. And then recently we got funding from CSIR on artificial intelligence applications in chemistry, biology, medicine, especially for cancer. And then we developed a lot of tools for AI. We thought that why don't we use this for agriculture? In that context, we got funding again from CSIR to work on precision agriculture in collaboration with other CSR laboratories. Today, what I am going to talk is the electronics hardware which we developed as part of this project and how it is helping data collections, how the data is going to help the farmers, especially Indian farmers, to increase their yield, productivity. Thereby, it is also helping reducing the energy, reducing the chemical load to the environment, because all these sensors which we are integrated and also going to integrate in future, which is very, very specific to agriculture, dynamic monitoring of crops and how the crop feels in an environment, especially in adverse weathers, drought situations, and as and when need basis, how to provide resources to the field or crops so that minimizing the losses, increasing the yield, how these AI based, precision agriculture based technologies going to help the farmers. First, increase the economy of the farmer, economic outcome of the farmers. Second, also helping the environment, which is one of the main important goals of United Nations. So I am going to briefly touch upon what is sustainability, what is precision agriculture. It is for the benefit of the beginners, maybe the newcomers in this field who are traditionally working on agricultural fields and other related fields. It is also an opportunity for interdisciplinary science, where people with chemistry, agriculture, computer science can come together to solve some problems and eventually helping the farmers, thereby food security. There were green revolution in the country. Today, next 10 years or 20 years, it is going to be IT revolution. Why not in agriculture? So I am going to touch upon what are the opportunities, what are the threats. That means if you don't act now, then we will be left behind. In that context, it's a threat. So I'm going to start with my presentation. The agenda for the talk today is okay. One second. The agenda for the talk today is what is sustainability and what are the sustainable development goals of United Nations. When someone saw the title of this presentation, they must have got curiosity. What is SDG? Why SDG? Why United Nations? How it is relevant to agriculture? I strongly recommend each and every one of you to look into Google or United Nations website. What are these SDGs? How you can contribute and complement. If we are not in that domain, we will be left behind. And then I am going to touch upon what is precision agriculture, how it is affecting or going to help the farming, especially in India. It is already implemented across the world, maybe Brazil's, USA, other countries, they are implementing this automation, robotics, networking, all the things they are doing precision agriculture. At the end of the day, it should reduce the cost, increase the yield. I'm going to little bit touch upon data is a new oil. So here we are, when you do the sowing and harvesting, you get the yield. But here, along with that, if you can monitor electronically what is happening from sowing to harvesting, how this data can be used for next sowing to harvesting, next cycle of crop. Then what type of crop you should put, what is the crop cycle, how you can use the land, energy, resources, labor very effectively because you are collecting the data. So historically, we never collected data. Okay, yes, we have some data, especially weather stations installed in nearby fields. But then how this weather station data is linked to the crop which is close to that weather station? This is what the precision agriculture is going to make a change, dynamic change. If you link how the plant feels when it grows from seed to seed, basically you can use that knowledge, that pattern for next cycle, thereby you can reduce the loss, increase the yield. So with this context, we gone through a lot of research papers past several years, and recent time, people talked about sustainability, people talked about precision agriculture, but in recent time, they are talking about sustainability using precision agriculture. That is why this topic is today for you. So I'm going to talk about, since we understood that precision agriculture is very important, I'm going to talk about what is our initiative with respect to precision agriculture. We did only this 2 years project, and it is the first time in the country. Basically, that project is called SAGITA. I will go into the details. It is executed by 3 institutions: National Chemical Laboratory, CSIO Chandigarh, and CMERI Durgapur. Because these 3 institutes are with 3 different expertise, NCL being chemical lab, CSIO being instrumentation and electronics lab, and CMERI is a mechanical lab, where they are doing a lot of research on agriculture. So we three of us came together, proposed this project. Why not complementing each other's expertise to develop something which will eventually help the farmers community, especially Indian farmers. In international level, there are so many there are companies like John Deere, many companies are working on these type of domains. But in India, it is not yet popular. So who will do this work for us? Okay, so we have to do some research and development, approach the industry. Through industry, can we reach the farmers? and eventually it become normal for the farmers. You can think of this telephony where people used PCO and today they are using mobile phone. That type of revolution is expected in precision agriculture, and how it is going to help eventually in sustainable development. So, and then in this project, we developed the cost-effective solution, that is cost-effective IoT-enabled trans-receiver station with multi-sensors and softwares. Why this is very important? So trans-receiver is like a honeybee going to the flowers, collecting the honey and coming back to the beehive. Similarly, here the trans-receivers are resident inside along with the plant, so that they keep transmitting the data, what the plant feels, what is the radiation, what is the moisture, what is the temperature, etc., etc., etc. All this data now using the sensors are transmitted to the base station, and then the base station again transmit across the country to cloud servers, where high performance computing infrastructures are established. These data, once it is collected from sowing till harvesting, can be a great wealth to decide how the plant performed in that environment. Can we use this pattern for next cycle of crop with better productivity, minimum resources, etc. So that's why we developed the multi-sensor hardware. Right now we put basic sensors because it is a prototype and a very short period project. And then prototype development, conceptualization, developing hardware, software, and integration, everything was done. Now in the next phase, we can go in details with different types of crops, different area, different locations, etc. So that's why we are going to collaborate with industry. That also I will discuss about this. And then I am going to touch upon what is the importance of historic weather data and how it is correlated with the crop yield. Crop yield is available in Indian government websites. What is the crop, what is the yield, what is the season, all the information is available. But then this historic weather data is available in another websites. So if I link these two informations, that is weather data in that particular location and then crop yield in that particular location, then I get something new informations. When you calculate the crop yield is already available, weather data is already available, and then the event which happened during that historic time, that is when the fertilizers were applied. Okay, what is the cycle in which fertilizers were regularly applied? Without understanding how much is loaded to the field. Then we found something very, very interesting. So the fields were overloaded with chemical fertilizers, and eventually it is going to reduce your crop yield, maybe. So then it will be heavy cost for the farmers and also to the government. So then N loading, that is a nitrogen loading. So this information is now two isolated collection of information. When brought together by adding some events, now you understand how the N loading patterns in that particular field. So this is where this data science comes into picture, robotics comes into picture, and then analytics, artificial intelligence comes into picture. So then we also used this hardware. To our surprise, this small low-cost hardware was able to recognize the adverse weather, and I will show in some of my slides how the adverse weather was monitored very accurately. Okay, and then I am going to discuss with other government agencies to correlate with our data with what they monitored in their sophisticated weather stations. Now I will also touch upon few case studies. Basically, we have to make seed to seed. So I took help of Dr. Milind in IISR. Then I requested, because one of my students was doing PhD in soybean research. So in that context, we used to discuss with him. Then when this project came, I requested him, I want a non-commercial, some experimental soybean varieties, which we can test it along with chickpea research, which we are doing anyway. So then he generously agreed to share some few informations and few data. And then we tried this in a very, very small field. And then because we are going to do seed to seed comparison, putting one seed, how many seed we get at the end of the harvesting, and then what are the condition in which the plant grows. It is this data is going to complement IISR research also. They are growing in very big fields, and we grown in a very, very small field, but each and every plant was monitored, each and every pod in that soybean was monitored, and the weight of each and every seed, the length of the plant, the seed, how it grown, how many pods in a plant, everything was very, very accurately monitored. And then we put some few research students on this topic, and 3 to 4 months we worked on these soybeans. And this is a prototype. At least we got some data. Now this can be, if the pattern is understood, we can expand this into big fields where the soybean is grown. Soybean is very important economic plant. I don't need to justify why soybean, but we also work on chickpea. So what are the problems will come? What are the insects comes? What are the other diseases comes to this type of plants? Everything should be monitored, and this will help eventually the farmers. Okay, so in that context, I am going to discuss about what the studies we did. First of all, hardware development, software development, and also case studies by planting soybean seed to seed calculations. And then once you know seed to seed, then you got the yield. So how this yield is correlated with your environmental data, which you captured through this precision agriculture technology. I will be a little bit touching upon the machine learning, deep learning, artificial intelligence for precision agriculture and SDG. This is traditionally we use machine learning, deep learning for our drug discovery, or defense research, and why not agriculture? So that's why this technology is already available. If you put the data, then the machine learns and develop the pattern. That pattern will help you for decision making. That is the new area where the newcomers can take advantages of these fields. You must be wondering, this person is a chemist, how he is talking about robotics, deep learning, machine learning. If you have interest, you can learn anything and implement. That is how I am here in this field. So now, because of our success stories, and we also filed some US patent, now it is granted, IoT for remote monitoring and controlling of physical parameters. And now that we did for medical context, now it is being used for agriculture. So when you develop one technology for one particular area, that same technology can be extended for related areas. So that is how this IoT technology, which we developed for monitoring transportation of vaccines and other biologicals, now in the same sensor technology now used in remote monitoring for agriculture. Now, based on our success story and patenting and IP protection, some industries also approached, we also approached some industry. I am going to talk about a few slides with my collaborator with whom we are discussing, and how to extend this in the field. Basically, these companies are directly linked to several regions within the country. They have a huge farmer connect, and their technologies are actually reaching the farmers, and farmers are benefited. So now, once they know that we are developing indigenously for Indian context and cost-effective things, then we develop make in India, made in India context. Why not Indian industry, which actually reach the farmers? I'm going to discuss something about it. Because we made cost-effective solutions, companies are interested to collaborate with us. And then what is the future direction? This is the opportunity for all the participants here. I see about 59 participants here. Each one of you are welcome to collaborate with us in project SAGITA 2. Because of this pandemic, this project is a little bit delayed. Eventually, it will come, if not one or 2 years. And if you are ready, we can join hands and we can make big impact in Indian agriculture, especially implementing this precision agriculture. And then the farmers get benefit, two, the government of India gets some benefit because we are following SDG, that is sustainable development. So that is what, and then finally I will conclude what we achieved and what is the roadmap for future. And also spend 1 or 2 minutes, what is the motivation and inspiration for me to pursue science in these related areas. So please feel free to ask me if you have any questions. One second, the slide is not going. Okay. So now I am going to talk about little bit about sustainability. Sustainability is not an isolated term. It is linked with ecology, sociology, and economics. So I recommend people in this who is attending this webinar to go through this important slide, paper, that is Precision Agriculture and Sustainability. It is slightly outdated publications, but the concepts, the application of precision agriculture in sustainability is very well explained. So actually they talk about several aspects, and main thing is I underline here, precision agriculture can help in managing those inputs in an environmental friendly way. Then I highlight here the spatial management of insecticides, herbicides can reduce overall applications of those chemicals by applying them only where the problem exists. The third point here is, just a second, PA can contribute in many ways in long-term sustainability of production agriculture, confirming the intuitive idea that PA should reduce environmental loading by applying fertilizer and pesticides again only where they are needed. So how do you know that when it is recalled? Okay. So you can see that environmental risk from nutrients and soil organic matters. So nitrogen, phosphorus, potassium, etc., etc. Then what are the process involved? Okay. So we saw this. Now let us go into. Okay, I'm sorry. Okay. So now sustainability and precision agriculture. I want to spend a few minutes on what is sustainability and what is precision agriculture. Once it goes into your heart, that then yes, it is very, very important. Anyway, we are doing science research on our patients and our job requirement. Why not in the context of sustainability? How the future generation can get benefit out of the research which you are doing today. So sustainability refers to agriculture and industrial technologies that reduced or prevented the environmental degradation, often associated with economic activity. So when we are growing economic plants like soybean, etc., there may be some load on the earth. So sustainability, the ability to maintain constant consumption and productivity by substituting between natural resources and man-made capital. So this includes your equipment, etc., etc. So this I'm giving very, very important definitions about sustainability. The human man-made capital encompasses everything, anything developed by human efforts, including physical capital, that is equipment, structure, etc. Intellectual capital, like information, knowledge. The natural resources, man-made capital, complement each other in production, process, and as a natural resources are the limiting factor of production, they must be preserved. Okay, this is the context of sustainability. What about precision agriculture? Precision agriculture is a management concept focusing on monitoring, measurement, and responses to the inter and intra variability in crops, fields, and animals. And precision agriculture aims to reduce the environmental impact of agriculture and farming practices, contributing to sustainability of agriculture production. I want to emphasize on these few points, one in the context of sustainability, another in the context of precision agriculture. Once you are convinced that these two are very important, okay, now you will focus on your research will automatically diverted towards this SDG, that is Sustainable Development Goals. This is benefit of people who never heard about, because I was also not aware of all these things until I entered into the research and work. Okay, now there is a lot of funding opportunities, collaboration opportunities by United Nations on this sustainable development. So first of all, it will help basically India. Why? Because one, they put all the important things in the context of no poverty, zero hunger. So when you look into these two things, where agriculture can play an important role, especially no poverty, and when the farmers are need not be poor all the time. If they can increase their yield and economically they can grow, and they no longer poor. And then because they worked very hard, then we don't need to have hunger. So these two things are very important. And if you look into these topics, I encourage, please go, all the participants, please go into details of SDG. Then I feel my time, efforts, and your time which you spend for attending this webinar is fulfilled. Okay, so I'm going to present the details of my slide is okay. Precision agriculture and environment. So now we can use precision agriculture for sensing, using the sensing technologies, management information systems, advanced in farm machinery. So if you can see that in NCL, we have this IT technology, which I worked several years, and machinery where this CMERI worked several years, and this robotics, this CSIO worked together. They actually came together for completing this objective. So the benefit of precision agriculture includes increasing crop yield, animal performance, and cost reduction optimization process. Basically, you have to take care of how much chemical load you are putting to the environment for the seed to seed. When you search the internet about sustainability and sustainable development goal and zero hunger, these are the terms which comes into picture. That means if you do data mining, you will end up with soybean, crop, malnutrition, food security, agriculture. You can see all the topics are there. Okay, alternative agriculture, digital agriculture. There are several ways in which they call. So basically, these PA technologies are three pillars of sustainability. One is economic sustainability, environmental, and social things. What we are doing monitoring, measuring, and response. Sense, analyze, and control. This is what happens in precision agriculture. So there is another one slide about the threats and opportunities of sustainable development goal. I am too much optimist about anything in my life, so I will not look into the threat. I will only look into the opportunities what this precision agriculture and SDG pose to our life. I highlighted these two topics, yes, because we can go in every topic, but preferably right now in the context of precision agriculture, you can see that AI and big data driven food supply chain optimization, improved manufactured food quality through sensors, yield improvement through precision agriculture. Now you can see clearly that zero hunger goal 2 of SDG directly linked to your precision agriculture. There are other, you must be working on several other domains. Okay, so you can see which is very much suitable for you. Accordingly, you can divert your science for your own satisfaction and also your institutional benefits. Now, I want to also stress upon Sustainable Development Goal 12, which is responsible consumption and production. What is SDG 12? SDG 12 provides information which allows consumers to be more responsible, reduce waste through better decision making across supply chain using prediction of harvest yield and quality to improve planning, reduce waste in storage through improved planning and by linking agriculture sensors with transport management systems to reduce food spoilage. So what we developed the transport management systems, remote monitoring and control for transfer of the sensitive biologicals now can be extended to this food transport. Okay, suppose for example, some very perishable items are being transported, it has to reach from field to customer without much loss. Okay, so these technologies can help now. IT, IoT technologies can help. And then the last point is reduce chemicals used and improve the long-term soil management through better planned crop rotations. So now the problem today in the country is we don't have good sensors. We have to depend upon other countries about the sensors required for agriculture. There is a urgent need for development of sensors. We are depending upon what is in the developed countries, but we need cost-effective sensors. There are certain situations where these sensors are very, very expensive and not affordable. And then once you put it in the field, because of these environmental and weather situations, and there is a possibility of corrosion, performance change in these sensors. So now there is an urgent need for development of robust sensors to monitor these parameters. That is the urgent need. So I am looking for collaborators in this field, okay, sensors for agriculture. So you have to identify what parameter you want, what type of sensor you need, what is the longevity of the sensors because the sensor should sustain from sowing till harvesting. If the sensor is not sustaining in that environment, that situation, and that where the crop grows, and then we will lose the data. If there is an error in the data, automatically there is an error in prediction and decisions. Okay. Now, I will little bit talk about precision agriculture technologies and management. See, this is a comprehensive slide, but then I thought it is very, very important for the beginners what these PA technologies are. So they talk about spatio-temporal variability, crop, soil, natural resources, big data mining, statistical issues in precision agriculture, IT system, information technology and systems, engineering technologies, computational intelligence, proximal sensing, remote sensing, variable rate application equipment, food security, climate change, conservation management, crop protection, horticulture, dairy livestock, nutrient, water, sustainability, education and training. So the participants, I'm sure you must be associated with one or any number of these topics. Now you can contribute in this domain. So then if you are a computer expert, you may not have much experience in agriculture. Still, you can contribute in precision agriculture. Here, I am talking about the modeling and simulation techniques used in precision agriculture. So whenever you talk about artificial intelligence, it actually the background is, or the backbone is, machine learning and deep learning. So the machine learning and deep learning techniques are used to understand some patterns from the data and apply that pattern on new data or new scenario. So for example, here I am talking about several techniques, modeling and prediction of future time series data. See, people use this future time sequential data. For example, stock market. People want to predict which stock will go up, down. So similarly, those algorithms which is developed for this other domains in computer science or statistics can be used in this agriculture, because this is also time series data. When you look into the time series data of weather, humidity, temperature, moisture, pH, nutrients, concentration, etc. These are all time series. With time, they keep changing. So once you capture the time changing or time sequential data, you can use this auto-regressive integrated moving average, ANN, SVM, this ESN, swarm optimization, etc. But unfortunately, for practical IoT system, these models cannot obtain accurate predictions due to complexity of collected data and weak modeling ability on non-linearity. So there are some non-linearity associated with this data. So when the data is non-linear, it becomes more complex for accurately predicting. You can predict, but you can't say that your prediction is accurate. Okay, when you have no knowledge, at least some knowledge is better than no knowledge, right? So now once you have the data, then extracting features of time sequential data, these are the information is used. The right hand side, what I'm talking about, CNN, RNN, LSTM, GRU, and LSTM by LSTM technology are now currently being used for feature extraction. Once you understand the data, now you can use it for your productivity. Now you may be thinking, okay, I talked so far what is actually known till date. Now, if you go back to the literature today, okay, sustainability and precision agriculture, you can see several articles. I'm just going to, just show you what are the top titles and topics now being published. Okay, there is a great opportunity for you to complement and contribute in this domain. Deep learning predictor for deep learning and PA in IoT. And then people talk about fungal disease warning, and then PA and sustainability in context of potatoes, olives, etc. Eye pathology, robotic application management plants, plant diseases. Advanced monitoring management systems for improving sustainability in precision agriculture. These are very, very recent. In last 1 or 2 years, these papers appeared. Okay, that means in next 10 years you can see how many and how much work is going to come. And I wish if these papers appear from India with some case studies, I'll be very happy. Okay, so augmented reality and IoT for precision farming, increasing profitability and monitoring environmental performance, a case study in agri-food sector, and the most importantly, the current progress and future perspective of agri-technology, gateway to sustainable agriculture. So I encourage each one of you to go through these publications. If you want, you can send me an email. I can share all the informations even in these slides so that you can start working on these goals. So now I will spend some few minutes about what we did. Now you are convinced that precision agriculture is linked to sustainable development. Now, one component of precision agriculture linked to monitoring crop environment, where the parameters including weather data. So we started with weather. We started with weather. To even to sense the weather, you need several components in this project. So what we did, so we in this project SAGITA, acronym for Smart Agro Informatics and Green Internet of Things, to enable Agriculture 4.0 SAGITA. This is a CSR sponsored project for the year 2018 to 2020. Okay, it's a very short period of time because of so many other issues. We could do something only, but there are more opportunities available now. We established many things under this project. We established hardware, software, etc. under this project. I will just go into the details. So when we can do it, I believe you can also do it. Identification of agriculture parameters to be monitored, finalization of suitable sensor system, collection of data relevant to targeted farms. This was the main objective when we proposed this project. Design and development of multi-parameter sensor nodes and the signal processing schemes. Design and development of data analytics algorithms and IoT toolkits. Training of the above and collected data, where we use machine learning and deep learning. IoT enabled system with field deployable multi-parameter sensor nodes compatible for agro-informatics with suitable green power sources for live data gathering and analytics. SAGITA platform integration with the prototypes with statistics and feedback. Okay, so now what we did. So the main goal of this project is, can we develop something to monitor the data? Once you have this base framework, you can add many more components. To develop the field deployable wireless multi-sensor for field data, and then big data, because the data is going to be huge. And then what is the frequency in which you collect the data also matters. And then it is integrated with machine learning, deep learning, and this is the main focus of the project. And then what we actually got, this is actually some related information only. Basically, we want a trans receiver, IoT trans receiver, to collect the data in the field, and then you should put it in a central repository where you can use machine learning, deep learning to use this pattern for further future research, future crop cycles. So now I will just briefly outline what are the agri-sciences data. So we, weather data, temperature, humidity, moisture, water, soil parameters, radiation, chemicals, etc. Crop yield. In this project, we collected these several data because this is the first of its kind in our setup, so that whatever the data we collected is now become a very big resource for future undertaking future big projects. Okay, that's why we are now trying to focus on SDGs so that we can expand the scope of the project to a bigger, large scale. Okay, so then we worked on soybean, rice, and wheat, chickpea, etc. And then I will go just details. This is a multi-institutional nature project where sensor integrate. NCL was working on sensors, chemicals, even some crops development, etc. And we actually collaborated with some industry partners to develop the new PCB because we want cost-effective solutions. We can't take the ready-made things which is used for teaching children, but that things will not sustain in the harsh environment where this electronics is exposed to sunlight throughout the day for entire the crop cycle. So it has to sustain that heat, radiation, moisture, rain, etc., etc. So we have to make a all-weather compatible electronic hardware for this particular purpose, sensors and electronic hardware. And then we want to use this solar energy so that where we can deploy in the field where there is no access to electricity is available. Okay. Then we used the cloud implementation, weather station, soil analytics. We did some variogram, soil variogram, nutrient variograms, etc. Chemical analysis done on the soil. Then our objective is to extend it further to pesticides, fertilizers, and then how this amount linked to the yield, etc. Basically, even plant health monitoring, imaging of the leaf, and then finding any disease, coloration, anything happened. So we want to use this visual computing for this plant health monitoring also. Okay. Now you can look into that. So the trans-receiver data comes from the field, goes to the machine learning, deep learning technique. Then we build the pattern. Now that pattern can be linked again with other parameters coming from government agencies. So I am talking about this IMD data. So all this data is now available: temperature, soil, water, specific humidity, crop yield, rainfall, maximum temperature, minimum temperature. All information is available. Actually, gigabytes of information and terabytes of information is available globally. But now the question is how you are going to use your technology and integrate with their available technologies. So then in our project, we made the cloud where this data from NCL, CMERI are linked using these cloud computing technologies. So now in the next phase, we will be implementing these drone related technologies. Okay, so now just for the beginners, what is this hardware contains? What is the weather station contain? What is the trans receiver contains? So the trans receiver usually contains a small microcontroller, and then it has a connection with the storage device. It has a networking device like Wi-Fi, and then LoRa technologies, and then different type of sensors, analog sensors, digital sensors. Once the output comes, it can be locally stored, and when the network is not a problem, then you can store the data locally. After that, when network is available, it can transmit to the cloud and it can go to the base station. And then you can have this microcontroller linked to relay other information, so like it is powered by solar, it has a timer. So then once you have the relay, and if your sensors are there and understanding the environment, it can take some decisions. Once you program the things, you can also, irrigation can be done, or some precautionary measure can be done. Some alert system can be created. Some siren can switch on, something like that. So this is going to be the future where the farmer can get the important information that what is plant is feeling should be translated into a farmer understandable format, such a way that he can take some remedies to reduce the loss, or automatically if he implement and understand how it works, he can see the minimum resource utilization and increase the yield. That is our main objective. Okay, so now this is a block diagram just to show that what are the components in the hardware. Okay, so now actually we developed this hardware. These are all deployed in the field. There are two types of hardware. You can see that this left-hand side is developed by NCL, and the right-hand side is developed by CSIO, these hardwares. And then CSIR, CMERI is also working on some hardware development, but their main focus is how to collect the data across the country using the cloud computing services systems, so that the data which is in the field, how the crop feels, is dynamically transmitted to the systems centrally in Calcutta. That is means Durgapur. Okay, so the CMERI, the data collects from two stations, basically from NCL and also from CSIO. So we developed this hardware, we deployed in the field, we used all type of sensors, BME, aerometers, all type of sensors, and then all sensors data were collected periodically, dynamically from the sowing till harvesting in a central cloud system. Now the next phase can go to, we already know how much yield we got. Now how to correlate, what are the parameters, what are the features data we collected from these sensors in the field is related to that particular output. So that once we understand that these are the important parameters responsible for yield, now we can optimize the condition in which the plant grows. Okay. So basically it was deployed in the field like this. The data goes in the next phase. We will be implementing this remote sensing and drone based technologies, etc. How it works? Actually, there is a node in the field. It goes to the IoT device, and then using this wireless and MQTT protocol, it goes to the cloud. And then once it goes to the cloud, the central server receives the data. So we implemented this software which we developed. This is a standalone software, SAGITA. It has sensor data, crop information, location, data analytics, hardware, sensor, etc., etc. Okay. Now these three locations you can see dynamically what is the temperature, weather scenario. All the information can be accessed on the click. So you can see that it is spatially very long distances there, but still that did not stop us collecting data and using it for analysis. So this each and every peak denotes one day. Okay, so you can see that the huge means almost 6 to 8 months of data continuously was collected without any interruptions. This is very first achievement in our system. It's a very low cost system, but still we did not lose a single minute data in this system. Okay, so this is just a sample. Okay, we got the sensor data into the cloud system, but now if you want anything relevant to agriculture, like I told you about this particular device, aerometers, which is very, very important, then you when that type of data also can be, time series data can be plotted. So then based on that conditions, you can enable relay systems to take care of the plant growth. Okay, so now the data is collected in this. This is a live data that we collected when the plant was growing. When the soybean was growing in NCL, so minute to minute we collected the data. Okay, so then the data is there. Then by date wise you can plot it. You can see that each peak which I shown earlier is one particular date. You can go and zoom how the temperature variation happens. Actually, this technology actually helped to even to monitor. When the cyclone Nisarga came, you can see that how the air temperature and soil temperature. The blue line is a soil temperature, and the red line is a air temperature. You can see that it was. This is the domain. This is the time frame where the cyclone Nisarga was, captured. Information is captured in that context. Now this is exactly being felt by the plant in the field. Okay, so then your yield may be linked to the variation, the air pressure. There may be so many factors are there. So now you can correlate. There is an adverse event happened during this crop cycle. This could be associated with your performance. Okay, so now you realize that how this sensor data can be linked. If the farmer is putting the seed and collecting, harvesting, he doesn't care what happens in between. Okay, maybe in the end he can have positive or negative. But now if you have this information in each and every field, every hectares, every acre, then it will really help Indian farmers in future. Okay, so that's why we need some collaboration. This is the historic data, whether linked to crop yield estimation, because the yield is also there. And then we found some interesting things. There is a trend in growing trend of yield year wise, and then it again decreases, again it increases. So it clearly shows that putting fertilizers continuously every year may be not good. Okay, maybe you need some gap between. This is what our observation understanding is, that too much loading of fertilizers also decrease the crop yield. Okay, I don't need to talk about this because I am not an agriculture scientist, but from our data, from understanding by reading the literatures, etc., we came to that conclusion. So we developed both standalone software, and we also made web interface, so that anywhere in the world people can watch what is happening in that particular field. This will be very useful for future generation of farmers, or the sons and daughters who are farmers, the sons and daughters who are IT savvy. They can monitor what is happening in their parents' field. Okay, so these type of things, and then you put the plant, we put some we just grown something for testing purpose from seed to seed. Then we actually grown, monitored, then we also monitored what happens to the plant, because when it happens here, it happens in real field also. What are the insects, what are the diseases, how to protect, when to put, what are the weeds grows along. So this is a very new experience for us. Okay, so then we actually from seed to seed we did that. Okay, experimental soybean field, and then similarly we tried with chickpea also. Okay, so from flowering, from seeding to flowering, all the information is monitored. One second. Yeah, so you can see that these are some of the varieties which got. But what is important here is 45 seeds per pod and 4.58 gram per pod. This is the very important parameter. We know that variety wise, which variety gave what seeds, what weight, and then what conditions. So people always get this information, but they don't get what is the associated data. So now, since we have the sensor data associated with this this yield, now we can use this machine learning, deep learning techniques. What are the factors responsible for increasing? One, it has an inherent variety wise yield. And can we increase under optimum conditions the weight of the seeds? So you can see that we did this, and we also extended in other fields, same studies. Now in the next phase, we will be implementing the drone technology, because drone flying requires a lot of permissions and clearances. So we postpone to the next field. Basically, this will really help. What happens? Okay. So basically what we did custom designed IoT stations, and it is just a weather station. We have commercial things. We want to compare our technology with what is these commercial stations are ranging from 2 lakhs to 6 lakhs rupees. But when we develop, we make it very, very cost effective. Okay, so then once it is optimized, if it is mass produced, it will be much, much cheaper, and it is affordable to everyone. And in every acre, you can implement one, that much cost effective, because once you get the yield, you can recover the cost. Second, then agriculture specific sensors needs to be integrated. We need, because the cost increases because of the sensors only. So there is a technology is already available. You can put any number of sensors here. So we made that arrangement that you can put any number of sensors to these devices, homemade devices. And then the cost of sensors should be cheap, because now it is not made in India. It is really a problem for us. We have to depend upon China and other international agencies for sending, getting these, sensors, field deployable sensors. And then their sustainability also very important. From sowing to harvesting, it should sustain. Now you can see that we have a data, we have the yield data. Now, using this machine learning and deep learning techniques in computational intelligence, you will be able to predict what factors are responsible for this yield. So then what is happening here is the data is very, very important. Once the data is there with you, you can see that what is the variety, what is the details. Then once you have these parameters associated with this data, especially how the plant was grown, and then that data will come into machine learning, where this computer intelligence, machine learning, AI can help even to why there is a good yield or bad yield. Okay, so a lot of work needs to be done. Still work is in progress, but in 2 years we achieved this much. Hopefully this patent was granted 2020, that this is remote monitoring and controlling physical parameters, and then we used the IoT device. So the same technology, this IoT sensors and technology, multi-sensor technology, is now being implemented in agriculture fields. So then we got the data, we grown the plant, now we put it into the high performance computing, now the models are being built, and eventually now the setup is ready. It can be deployed in any fields for any crops. So here I want to highlight the team CSIR, where NCL, CSIO, CMERA work together. I'm just showing the NCL team, Dr. Kadu, Dr. Ingle, and then Dr. became money. So they are all work together to make this happen. This is from NCL team. And here, this is the agriculture knowledge base comes from Dr. Pradeep Rajan from CMERI and Rajesh Barnwal, who is a computer AI tech expert in CMERI. So he took care of all these cloud-based systems. And whatever is made local, made it available across the network. And then Dr. Mr. Baljit, CSIO, who actually fabricated the hardware, so cost-effective hardware. A lot of efforts gone in that, but at least we got some results on this. So now I will spend a few minutes, maybe 5 minutes, to tell whatever we did attracted the attention of industry. Now we are trying to collaborate with this industry. This is for the benefit of people who are interested to enter this domain or want to collaborate with this. I want to tell that this company is very open and they work with real time and then with the farmers in the field. Okay, that attracted us, because if you develop some technology, if it is not reaching the farmers in Indian context, it is no use. So we don't want just publications and patents and accountability. We want it should reach the common man. So this company actually works in 3 states, Haryana, Odisha, and Tamil Nadu. So once our technology is optimized and technology transferred through proper channel, then they can implement in these domains. They have some complementary expertise. So they are also working on these softwares, and you can see that their main objective is how to help the farmers, and it is actually meeting the SDG goals. So that attracted us to collaborate with them to handshake. I think they also visited or discussed with IASR. Okay, so all these tools, whatever they are developing, we are also developing. It is complementing without competing with each other. So then eventually we will make the IP and transfer so that they can freely implement in farmers field. At the end of the day, farmers should get benefit out of this. I will just skip some of the slides. You can get it from their websites. Basically, what they do, the one slide I say, from sowing and then monitoring and then harvesting. So they are helping even the farmers to get the loans based on the crop conditions in their field. Since they are showing live data, the bankers or the investors are actually trusting this company to connect with the farmers. So it helps the win-win situation for both the farmers and also the bank and also the intermediate companies facilitating this precision agriculture. Otherwise, the farmers have difficulties in getting the resources. Once they get since the crop yield is monitored and alert systems, the farmers actually get benefits. So one case study actually impressed me. I'll just show you. So they work on so many other areas. Actually, eventually, once we develop our strategy, it can go there. Right, so they have all the related technologies, for example, farm identification, georeferencing, land specific data. These are all very important for SDG goals, soil data, etc. And then radiation data, how the land is used, classified, all the informations they have. Okay, so you can see that automated health assessment based on the remote sensing data, yield estimation. Actually, it is meeting, it is complementing our research. That is the main reason we want to collaborate with them. Okay, you can see that maybe if you're interested, you can contact your registry. So the main thing which you can see in farmers' perspective, I received both generalized inputs such as weather prediction inputs, soil status inputs, customized crop specific inputs such as health of my crops, predicted yield given the current status of the crop. The second thing is, I learned that I had not replanted them systematically. If I had left them their present unsystematic order, then the weeds would have taken away all the nutrients from my crops, leading to suboptimal crop health and would unnecessarily increase my spending on fertilizers. So you can see that how these IoT, monitoring alert systems helps the farmers in real-time scenario. But tomorrow, there is no need of manual intervention. The AI system actually gives the alert system in mobile or these smartphones and systems which they have access. Okay. So in conclusion, I am almost close to my presentation. Maybe 1 minute I will take. Sowing to harvesting economically important crops. But that means data is oil. That is, data is very, very important. Now you are convinced that the data collected while plant is grown is very, very important, and it is helping the SDG goals. Then dynamic data collection, weather parameters, nutrients, pest control also very important. Spatial variability mapping, some soil parameters also very important. And AI, ML, DL techniques, or there is opportunity for utilization of those techniques in our yield prediction based on the data collected. Then there are other domains like IoT, robotics, drones, remote and automation, autonomous machines. Autonomous machines means the tractor in the field can go without human intervention, which is controlled remotely. Okay, so then these type of things can save the labor. It may save the labor, but it can also use it labor very effectively, efficiently. Okay, then actually I am looking forward to collaboration with ICAR. I mean, say ICAR institutions like IISR, so that if future funding and projects can be, undertaken. Future projects can be undertaken with the help of support from ICAR, DBT, other industry collaborations. I am welcoming all of you to contact me if you're interested in any of these areas and collaborate with us based on your expertise. As we collaborated with two more institutes and industry, now it is very easy for us to open our hand to join hands with others to help at the end of the day the farmers. Okay, so you please take it very seriously, and please feel free to call us, contact us. Since it is a pandemic situation, personal visit may not be allowed, but we can always available contact by email. In the end of the slides, I gave my contact details. You can contact me. So now, next 1 minute or so, in the agenda only I mentioned that what is the motivation for me to pursue science. So I was so inspired by this best Indian scientist. So from childhood, I thought, okay, one day I will pursue, I'll take science as a career. So then there are some best Indian scientists, men and women, the best women scientists. I don't know. There are right now still 52 participants are there. I am believing any one of you or more can come in the future slides of me or the future generation of presenters. Okay, if you take it this particular topic, that is precision agriculture for sustainable development. Okay, so now very specifically, since I worked in defense in 1999 and almost 2 years I worked when Dr. Kalam was leading the DRDO, I had a personal interaction with him during those 2 years. It was really very nice time. And then he became president, and really he motivated. He came from very humble background and reached the highest. I don't need to tell anything about him. He always motivates me. He is always in my desk. Okay. Another person whom I interacted when I joined NCL in 1990 was Dr. Arya Mashilkar. He was so open-hearted person that he can interact with even JRFs. We can't even imagine talking to HODs, directors, are very, very difficult for us at the students level. But this gentleman, Professor, with Padma Vibhushan, Dr. Arya Mashilkar is a very big heart, and he has a ear for every student. So when I was a student, when me and Milind were the students that time, I used to talk to him. Even I used to walk into his office if I have some problem. That much freedom I had. So last 30 years, he constantly, somewhere or other, I get some support or encouragement or wish from him, even in Twitter or social media. So really, these two individuals made important, inspiration and motivation to my research career. So that is the end of my presentation. Thank you so much for your patience, and let us collaborate in SAGITA 2.0. This is a 2-3 years experience for us, but your 20 years of experience in data analytics, robotics, machine intelligence, we can work much better. Okay, at the end of the day, our efforts should reach the common man. So I thank you all for patience listening, and I especially thanks Dr. Milind and the colleagues, Director, ISR, and HOD, Head of the Department, whomever is associated with this webinar and initiatives, and the participants for giving me opportunity to speak about my passion. What I did is just a drop in ocean. The best is yet to come. I always believe in that. And this success and failure gave us a lot of lessons that will help us to undertake the second phase of the project in a much effective, with very intelligent and very committed people. And we are looking forward funding in CSR, DST, DBT, DB, etc. And I also like to thank all of them. My contact details are there. You are free. Please feel free to talk to me. My core area of research is chem informatics. I believe in practicals. You must have seen my presentation also, mostly practicals. Okay, so I believe in practicals. I believe in theory. I learn from theory, but I believe in practicals. So with this, I like to conclude my presentation. Please feel free to ask me if you have any questions. Thank you.
Dr. Karthikeyan, first of all, I will congratulate you for the excellent presentation. It was highly informative, very interesting. You covered wide range of areas from precision agriculture to machine learning, deep learning, and a lot of things. So this type of technology is very new in the country, and our institute and several ICAR institutes will be definitely looking forward to apply these technologies in their crops. So thank you very much, and now I will ask a participant if there are any questions. Please go ahead and you can ask Dr. Karthikeyan.
I can see some chat questions are there.
Hello.
Yes.
Hello, sir. Are you listening? Hello.
Can you hear me?
Am I audible?
Yes.
Hello.
Yes, please go ahead.
Sir, first of all, I would like to congratulate you on presenting such a wonderful topic, sir, and it was really very informative. Sir, I'm Viraj, and my name is Viraj, and I work here in Indian Institute of Research as a scientist in molecular biology biotechnology field. So I have some question to ask you in this about this machine learning and deep learning you mentioned in your presentation. Sir, how to use this machine learning and deep learning in molecular biology and genetic engineering experiments? So that is my question. Since you are having expertise in chem informatics, so that would be also a area where you can enlighten us about how to use this informatics area and to apply with the help of this machine learning and artificial intelligence technologies.
Okay, so let me go to one slide. I think you got inspired by this picture. Okay.
Not just only that, sir. As soon as I heard about the topic, then I was very much clear that this area where I can ask these questions, and I'm really happy to see this information what you are sharing right now. But sir, these are all agronomical traits you are highlighting over here, and I'm very much interested in a molecular experiments, molecular field. Which is a little bit different than this one.
I know. See, I understand your genomics context. Okay, so I am basically organic chemist. I understand atoms, bonds, molecules, interactions, everything, right?
Yes.
So we used this AI for cancer drug design. So cancer is that topic is very, very special. We got a huge funding for that. So where we used how to make a drug exclusively for particular patient, because all drugs cannot work for all. So we have to identify the genomics of the person, and then how it helps the particular person, how to design a drug which works only for that person, not for others. See, paracetamol, aspirin works for everybody, but the cancer drugs are
very specific to the patient,
unique and special. So in that context, I recommend, okay, I will go to the last slide now. You please put your queries which is not relevant to this particular presentation. My presentation, I focused, usually I talk about my area of research, practical chemoinformatics, etc. But in this particular presentation, I try to avoid totally the molecular aspect, because I can tell you, once upon a time, I want to become agriculture scientist. I wrote the exams when I was pursuing my PhD in NCL as a JRF. But then today, I'm very happy to talk to all the agricultural people, agriculture scientists. Okay, so that actually still 45 participants are still there. So anything not associated with agriculture, you please post your questions to this email ID. Okay, identify yourself and tell that you attended this meeting, and ask your specific questions. We can collaborate. Okay, so not a problem. And I will give you detailed things, because this molecule related information may not be relevant to all the other participants. I don't want to losing the participants. Okay.
Okay, sir. Sure. I'll let you know, sir. I'll be contacting you through this
Please.
email.
You talk to Milind, and I'm always available.
Oh, thank you so much, sir. Thank you for such wonderful
Sorry, I
presentation.
don't want to distract or divert the topic of this presentation.
Okay. Have a good day, sir. Yep.
Hello.
Yes.
Good afternoon, sir. I'm Dr. Balakrishna from Indian Institute of Horticulture Research, Bangalore. I'm an agriculture extension scientist and also practicing a Paleos farmer.
Okay.
I have already sent my questions through chat. Two queries. One is you have given an excellent presentation on multiple aspects of this technology. It's good. But I was wondering how we can integrate with the use of UAV in this particular technology to enhance the precision farming. That is first question. Second one is, in case if a small farmer
Wait.
2 acres,
So let us finish one and then go to the next one, if you don't mind,
okay.
Balakrishna.
Okay, sir.
Okay.
Okay,
so
sir.
UAV,
Please. First
I
one.
recommend you go to because UAV I've seen they used for even spraying pesticides in difficult time. Okay, so they use the pesticide spraying. Actually, Anna University, there is a professor, I forgot his name. He's an expert. See, he's creating the UAV, which is high load payload. It should have a high payload. Okay, so then if it is integrated with the system, as soon as you receive that there is a say for example locust attack in the country, okay, so something happens where we never know what is going to happen. You and me, if you feel rain is there, we can take umbrella, hide somewhere. But what about the plant? So plant is facing all the time some adverse things. So all this technology is going to help. But unfortunately, UAV I did not mention because it has a lot of restrictions, and people can misuse it. So what is second question?
The second question is, what is the cost of this technology, what you are planning? Because even when we use the UAV for spraying with a high payload, sir, we have proposed many projects. It was rejected because of the cost. Only the major drawback in agriculture is we cannot keep on investing, even though there is a small marginal additional output in terms of quality.
Can I
and
tell
higher
you?
yield.
See,
But the investment also.
Balakrishnan, I agree with you. And UAV farmer cannot afford. So what farmer can afford is a service. So today, if you want to talk to me over the phone, you don't need to invest on towers. Okay, so there is an idea is the reliance.
That is that.
Okay, so once this technology is matured enough, okay, so it can be on subscription based systems, right? So then you get the profit out of availing the service. Because you got the profit, these companies will evolve automatically. See, electric vehicle today, it is the same situation. You can't buy the station, but now people are setting up electric charging stations, right? So in the beginning, people always reject, people will criticize, people will scold you, beat you, but you win. So don't lose the heart, continue your passion.
Thank you, sir. Thank you so much for your answer. Thank you.
Dr. Milind, it is 12:15 exact time.
Yes, there is one question from Dr. Shailaja from ICR Rice Research Institute. So can you just have a look at?
Yes, yes. Where it is Shailaja? Is it Shailaja?
Hi. Yes, sir.
Yeah, why
Really,
don't
sir,
you? Yeah.
presentation is very, very interesting, sir. Really, we are also working in the same line. Actually, I have one specific query, sir, regarding the weather data forecasting, sir. Whether this model is giving the accurate weather forecasting, because without weather forecasting we cannot generate the advisories on crop management, no, sir. That is
See,
my
I put one
main.
slide exclusively for you. I know this question is coming. Okay, so it is like say stock market forecasting. Okay, so today which one will go up, which one will go down. Okay, so that I can invest and harvest. Okay, so for that, because it's time series data, I put some technology here.
Okay, because I have seen in your slide that historical data and
No,
crop yield
historical data, I will
data.
explain 1 second. So before that, let me complete your question. That is yes. So for practical IoT system, these models cannot obtain accurate prediction due to complexity. So what we are talking, modeling and predicting of the future time series data. Okay. So what you are asking is future time series data. For that, use this auto regressive integrated moving average. So this is what is
RIMA model only. Okay. We know, sir, because we are trying with these models and
not see, it is very clearly written, cannot obtain accurate prediction. Okay, but then no, some model is better than no model.
Yes. That is correct, sir. Because now actually crop models are there, climate models are there. Because I have almost tried with climate models, sir. Climate models, those models works with temperature. Those models are not perfect for rainfall and all. So like that, many for each parameter, some constraints are there, sir. So we are trying to integrate with ML models and the climate models and all, like that parameter wise we are doing, because I am facing the difficulty and all. That's why I wanted to.
I understand, madam. See what happened. This one particular question. This when you say historic data, I will go into historic data. So this slide is very, very important. Okay, we handled almost 12 or 15 TB of 15 GB of data. I don't know exact how much huge data we managed, and then our final conclusion was our pattern recognition was different, but our conclusion was we observed some pattern that they suppose they put every 3 years these fertilizers, and then what happens to the field? They blindly they put. Okay, so so I don't know what is the government policy. Okay, but now since they did not study the pattern with respect to the yield, and when they put the fertilizer, sometimes it goes up and decrease. You can see that.
Yes. But always they will show that if fertilizer they apply more, yield will be more, like that. I
No,
will
what I'm
see in
telling,
our
that is not
presentation,
SDG.
sir.
See, main idea of this presentation is don't do work blindly, because one of the farmer in Divara, they mentioned that he would always follow the protocols of what parents, grandparents told. Okay. Today, with the help of sensors or your grandparents, grandparents, or dynamically the environment is changing. We have to adapt to the change.
Yes.
So let us start now. I am very thankful for your question. You please continue to work on your topic. You may not get the good results, but one day your photograph will come in my future presentation.
Maybe, sir. Really, I am trying for weather forecasting. I am spending so much time because
Madam,
so much
I think you
historical data
deserve.
is there with us.
See, a lot of space is there in this last but one slide. See, I can reduce the size of these pictures. I can put your photo one day if you succeed. Okay, I don't need to put. People will put. I have to just copy paste.
Thank you very much, sir. Very interesting presentation. Really, maybe I will mail to you, sir, regarding my other queries and all. And
yes,
thank you very much.
Let us collaborate. Okay.
Okay, sir. Thank you.
So you please write to me. No problem.
Yes. Yes.
I thank Milind for connecting me to the people. Thank you, Milind.
That's great. And there are one or two more questions are there from Dr. Sharma. He's asking about real-time farm model stimulation, right? Simulation.
Dr. Sharma.
Mahavir Sharma and last.
Mahavir PH.
Yes, sir.
Are there any real-time forms from which model can be simulated as current models are being computed from metadata? Okay. So see now, right now this area is not yet matured enough to reach the form, right? So that is the main reason we are planning to collaborate in the second phase of the project with industry, so that your question can be answered after that. It may be there in Brazil, it may be there in USA, but I don't have any access to it. John Deere, if you ask, they have this data. I can tell you right now. We visited John Deere. We know what they are doing. They are also interested in our project, and they are doing across the world. Okay, so if you see John Deere websites or something like that, this type of information can be available, and they are using extensively. We don't have. We started 20 years late, Dr. Sharma ji. That is my answer.
Thank you. Thank you.
Is it satisfying or not?
Sir, I think, I have taught so much, and it was really mind-boggling to all of us. A wonderful talk you have given. And only thing, it was my apprehension, because I'm a microbiologist, and I don't know that it's a big area you are working on. But I was just wondering if any real-time forms are available. But as you already said that we have started only 1 decade back. So maybe in coming time we may get some such forms.
Yeah, I told SAGITA 2 will give you 2.0 will give you real time, means maybe some prototype real time, but SAGITA 4.0, which we are thinking in future. Okay, definitely. What 4.0? Today people are talking about industry 4.0, where machine talking to machine. Okay, when we talk to machine, it is 1.0. When machine also talk to us back, then it is 2.0. Basically, when the machine talks to machine takes the decision when to put the fertilizer, when to grow, what to do, when to harvest. All things are going to come. Now hydroponic technology is coming, automatic harvesting of palak is going on. Okay, so things are going to come. When machine talks to machine, I think I don't need to answer. I think it is going to come. But only thing is we should not be left behind. See, you told you belong to one particular field, but I belong to chemistry. You please see. Anybody can learn and implement.
Okay, so I think we had a very nice session today, and I would like to thank Dr. Karthikeyan for once again for this excellent talk. And I also want to ask a participant to that they are freely they can write to him for any collaborations. And he's also very simple and kind person, and in a very short notice he agreed to give this talk. So I'm thankful for this.
Okay, can I tell you, Milind? So it was 24 hours time given to me. All the slides I made it in last maybe 12 hours.
That is amazing, and it is really because of your huge experience in this field. So that time I think it's sufficient for you 24 hours. So thank you again, and I'll give vote of thanks once again to our director, Dr. Neeta Khandekar, for full support for this webinar. Dr. Sanjay Gupta, head of the crop improvement, for again encouraging in this. And there are a lot of team involved, the IT team, Dr. Savita Kule, and her team is there who has provided support, Dr. Baraskar, and other staff from Indian Institute of Soybean Research. I also thank all the participants. Because of you, this webinar has been very successful, and we are looking forward to have interactions with you in this field once again. So thank you very much, and thank you very much, Dr. Karthikeyan, once again.
Yeah. Thank you so much, Milind, for giving opportunity. Okay, thank you all participants. Please feel free to write to me. We will work together. Thank you.
Thank you. Bye-bye.
Can I leave you now?
Yes, we can.
Thank you.